Hi, welcome to another episode of Qt QML tutorial. Today I will show you what signals and slots are in Qt framework. There will be no QML yet, not in this, not in next two, maybe three episodes, but be patient. First, we need to have a solid understanding of C++ part of Qt. My name is Lukas Kasiński. I am a CEO of Site Studio, Qt QML consulting company. We help our customers achieve their objectives by providing them with skilled Qt developers. In every application, there is a sequence of actions that have to happen. Some of them should happen after a particular event, some other action after another event. And imagine you develop a browser like Google Chrome or Internet Explorer, Firefox. The user has to type some phrase and then submit the search, and browser's engine do its work. Let's say that on the logic part, on the code part of the browser, we have the input field and browse engine, and both are objects, and they do not have anything really in common, right? However, they still need to communicate. So this communication, this is exactly what signals and slots are for. And this is the thing that you will learn today. Qt signals and slots mechanism has been part of the Qt framework since the very beginning. But why was it actually introduced? Well, they have been introduced as the clean alternative for other solutions such as implementing custom observers or callbacks. Callbacks used in C and C++ were sometimes a bit cumbersome, I would say. Let's say that we have object A and object B. Both are instances of classes named the same way. Object B has a method called doSomething, and object A has the method performOperation. Object A and object B are not connected to each other, but yet we want object B to do something after performOperation is finished. To do so, we would need to execute a callback that would have to be passed as the method parameter, or it would be needed to be registered in some other way. It may work fine, but in the long term, such code is quite difficult to read and easy to break. Also, debugging such chains of callbacks can be an issue. So, how Qt does it? The approach of the Qt framework is fundamentally different. Instead of defining callbacks and then passing or registering them, you have to emit the signal and make a connection between the signal and the slot, which can be actually a regular function. In practice, signals and slots are like a notification system. Object A announces to the world, I am done, and it does not even care what others do with this fact. Then we react to this information by making a connection between this signal and objects B doSomething method, or so-called slot. But how do I make such a connection? Well, you simply need to do a few things. First, ensure that your classes inherit QObject and use QObject macro. You will learn more about them in one of the next episodes about meta-object compiler. So for now, let's ignore this. And then you need to declare your signal just like any other method, but after signals keyword. You can also mark objects B doSomething method as public slot, but this is not necessary. And once you have this, you need to make a connection by calling a connect method. It is a static function that we can use thanks to QObject superclass. Connect takes 5 arguments, but the last one is default, so let's keep it quiet for now, and let's focus on the first 4 arguments. Those arguments are sender, pointer to the object that emits the signal, signal, pointer to the signal method, receiver, pointer to the object that listens to the signal, and method. It's a slot function that is actually executed after signal is emitted. It can be either a member function, functor, lambda, or non-member function. Also, from time to time, you may see old syntax of this function using signal and slot macros with capital letters, but it's not used that often in the modern Qt applications, so let's skip it. I just mentioned, so you know. And this is how connect would look like in this abstract example. We would have object A as the sender, pointer to signal I am done, object B as the receiver, and pointer to objects B do something member function as the slot. The system is quite flexible. One signal can be connected to one slot. It can be also connected to many slots or even to another signal, and of course many other signals. Connections can be done between different objects or within the very same object, and the important thing here is that signals and slots must match parameter types. Okay, time for some practice. How will a practical example look? We will code a simple console application that will mimic a browser. There will be a class user interactor that will ask user to input to type in some phrase to look for. We will also have two other classes, Firefox and Internet Explorer. The first will give us results fast, and the second one with some delay. We will need to use QTimer to implement such a delay, and QTimer is a class shipped within the Qt framework that allows us to implement timer-like actions. And how the communication between those objects will look like. Let's see, what do we have first. User interactor will have a signal phrase typed with string phrase parameter. Firefox will have a slot function named browse, also with parameter. Internet Explorer will have signal browse requested and also the slot named browse. And QTimer goes with own signals and slots, among which there is a timeout signal and start slot. In our example, signal phrase type will trigger both Firefox browse slot and also Internet Explorer's browse requested signal. As we want to implement the delay, emitted browse requested signal will start the timer. And after 10 seconds, the timer will emit a timeout signal, and this is connected to Internet Explorer's browse function. Okay, I have prepared some base code for this episode, so we do not need to implement everything from scratch. So user interactor and Firefox classes are here. You can see that user interactor has a signal emitted, and actually emit keyword does not do anything, but let's use it so you know that called function was a signal. And also notice that Firefox class has a browse slot already implemented. We only have to implement one class, Internet Explorer, that will have a timer inside. And then we will be able to connect to everything. So let's do that. Let's right click on the sources and add new, then select C++ class, and let's make it based on QObject. Qt Creator will automatically include the necessary header for you, and also remember to check QObject macro checkbox here. This is required to use signals and slots, but the details in one of next episodes about mock. Now let's name our example, our class Internet Explorer. I like using upper Pascal case for file names, so I'm changing file names here. Then click on next, finish. Class files were generated, but we need to manually add them to the cmake list txt file. So if you click yes, the paths will be copied to clipboard. Then you need to add them to the executable like this and save your cmake file. So you can see that a new class is detected correctly. Let's add here browse requested signal. You do that just like when declaring any other method, but under signals scoped keyword. So type void browse requested and the parameter. Signals function do not require any definition, any body, and it would actually raise a compiler error. Now the slot. It does not need to be declared in public slot scope, but let's do this. So type void browse. And it will need a definition. So let's hit Alt plus Enter to trigger refactor menu and choose add definition in Internet Explorer CPP. For now, let's keep it empty. And we also need a timer to slow down Internet Explorer. So let's include the header file of QTimer. And now we need to create instance of QTimer. Let's add it as a private member. QTimer m_timer. We need to set it now properly. So let's go to constructor and let's use mtimer set interval function and let's put 10,000 here as it takes milliseconds as argument. And let's also set single shot to true to make timeout called only once. Okay, so we have everything to make the connections. Let's remind ourselves how the flow of the signals and slots need to look like. Let's start by connecting user interactor with Firefox and Internet Explorer. We will go to main CPP and include necessary files and create the instances. So let's include the classes, include Firefox and Internet Explorer. And now let's make the instances, Firefox and Internet Explorer. Now let's make the first connection between user interactor and Firefox. We do that using QObject static connect method. First argument is sender, and in our case is interactor. Second argument is pointer to the signal phrase typed. And the third argument would be receiver, so in our case, Firefox. And the last argument is pointer to browse slot of Firefox class. Notice that signal and slot have one argument. Therefore, signal will pass the value of its parameter to the slot. So that's how Firefox know what user typed in. Yeah, now let's start the app and test it out. We need to type something, so let's look for some guinea pigs. And voila, you can see Firefox returned results immediately. Let's now close the app and implement other connections. We still miss many. Now we will connect the phrase type signal with Internet Explorer browse requested signal. And as mentioned, a signal can be connected to another signal. Moreover, one signal can make more than just one connection. So let's do this. Let's start with QObject connect, interactor, Again, phrase type as the receiver Internet Explorer, and as the slot browse requested from Internet Explorer. It is here, but it actually ain't nothing because there is no connection for the timer. Let's then make a connection in Internet Explorer's constructor between browse requested signal and QTimer's start. We write connect, and sender will be this as Internet Explorer emits browse requested signal. Let's point to browse requested as the signal parameter, and receiver will be mtimer. And now, normally you would do QTimer and start like that. However, it throws an error here. That's because start is overload method. One version takes no arguments and the other takes milliseconds. And to deal with this error, we need to put QOverload function before, and it's a template function, but notice that we do not put here any type as we want to just call start with no arguments. Okay, so now time for a second connection. Let's connect timeout signal, which is invoked after the timer is done. So sender would be timer, signal timeout, and receiver would be this. And as a slot, we will invoke browse function. Now let's add some body to the browse function. Let it print something to the console. We need QDebug header for that to be actually able to print to browser to the console. And here we will print some real life example. Now, okay, let's test it. Let's search for Qt docs. And as you can see, Firefox returned results immediately. What about Internet Explorer? After 10 seconds, we got our response. So yeah, our entire chain of signals and slots is working. I hope that you like this episode. In the next one, you will learn another typical Qt feature, which is also really important. So let's jump to another episode right now.